So, hi students. Today we are going to discuss about the perturbation theory here. So, perturbation theory mainly focuses on to find this appropriate solution to a problem that cannot be solved exactly. So, so what is perturbation actually? It is a it is a disturbance we can say. If we consider a system here, if we consider a system which is having an energy, so it is having an energy. Let us say E is the energy or E1 is the energy. So before disturbing this system, if you won't disturb the system, the energy may remain constant. But if you apply an external force or field on the system, if you apply external force or field on the system, what happens? This force or field will change its energy, isn't it? The energy might be increased or decreased or might be changed to E1 plus E2. E2 might be the due to the external agency or external force energy. So total energy is given as like this. So it has some wave function also. Let us say psi 1. That psi 1 will also change, and Hamiltonian it might be having that Hamiltonian is also changing. So when you disturb a system, when you disturb a system, you must add some energy wave function of Hamiltonian. That is what called perturbation actually. So here the perturbation theory is what the theory perturbation theory is a mathematical framework. It is a mathematical framework which is used to find an approximate solution, which is used to find an approximate solution to a problem that cannot be solved exactly. By exactly solvable solution, if we cannot find the solution of of any equation, we can go to an approximate solution by using a perturbation theory. So here we have defined here a system on which external force or field acts, so that external Hamiltonian, perturbing Hamiltonian, that is external Hamiltonian is what? Perturbing Hamiltonian has to be added to the original Hamiltonian. To the original Hamiltonian, we are adding perturbing Hamiltonian. So therefore the system is said to be affected or perturbed. The system is said to be perturbed. Then the Hamiltonian operator in Hamiltonian operator H representing the total energy of the system can be written as. So capital H indicates the total energy of the system actually. So here H naught is the unperturbed Hamiltonian. Unperturbed Hamiltonian means before disturbing the system, which is having a Hamiltonian, that is H naught. After disturbing the system, the external force due to the external force or field, this perturbed Hamiltonian which has to be added by S. So this is what the perturbation actually. So in the same manner, we are having a wave function also. So when it is about the Hamiltonian total Hamiltonian is equals to H naught plus H prime, where H naught is the unperturbed Hamiltonian. H naught is called unperturbed Hamiltonian. H prime is called the perturbed Hamiltonian. So in the same manner, psi is a psi is a total wave function if I say, and psi naught is called a psi n naught or psi naught is a wave function, original wave function or unperturbed wave function, where psi is the perturbed wave function. En is the energy here, eigen energy, and E naught is an unperturbed energy, and E prime is a E prime is a perturbed energy eigenvalue, we can say. So these are the H prime, psi prime, and E prime are corrections or perturbations here. So Hamiltonian H of the perturbed system is, you can write Hamiltonian H as H naught plus lambda H prime. So or H1. So H naught plus lambda H prime. This is unperturbed Hamiltonian, this is perturbed Hamiltonian, and lambda, or we can take any uh, parameter like epsilon. Also, we can take here lambda will change from 0 to 1. It is a constant which is changing from 0 to 1, which gives the strength of the perturbation or order. Okay. So we will try to expand this Hamiltonian H wave function psi and E in terms of parameter lambda. So in terms of lambda, try to expand Hamiltonian H and psi and E. Let us see the expansion here. So we can expand the system as like this. So H cap is equals to H naught plus lambda H power 1 plus lambda square H square lambda cube H cube, and psi is equals to lambda naught plus lambda power H power 1 lambda power 1 lambda square psi square, etc. or go on. So E is equals to E naught plus lambda power 1 E1 plus lambda square E square plus up to so on. So here we have lambda 1, lambda square, lambda cube. These are what? These are the parameters which indicates the strength of the perturbation. What does this indicate? Which indicates the strength of the perturbation or order of the perturbation. Whether it is zero order or first order or second order, we can tell by using these parameters. By seeing these parameters, we can say the order of the perturbation. Either it is first, second, or third order perturbation. So the external agents acts on the physical system could be time dependent or it could be time independent. The agent which is acting on the system, it might be time dependent or time independent. On the basis of time dependent and independent, this perturbation theory is classified as two classification as done on the basis of time dependency and time independency. So first one is time dependent perturbation theory, and the second one is time dependent perturbation theory here. So in the time dependent perturbation theory, this can be also called actually, this time independent perturbation theory is also called a stationary perturbation or else Rayleigh Schrodinger perturbation. So by using psi is equals to E psi formula, we will try to solve the solutions for this time independent perturbation theory. Again, this time independent perturbation is classified as non-degenerate case and degenerate case. There are two cases in this time independent perturbation theory. First one is non-degenerate case and the second one is degenerate case. In the non-degenerate case, we can take an examples of 1D box and linear harmonic oscillator. In the degenerate case, we can take the example of 2D box, 2D and 3D harmonic oscillator. These are the examples for the degenerate case. I hope you have understood the class. In the next class, we are going to discuss on the time independent perturbation theory, and that is non-degenerate case. We will focus on the non-degenerate case. Thank you for watching the class. Uh, Thank you.